Okay, maybe we wait another 3 more, okay, to enter the class. Okay, today we will start a new subtopic, okay, 3.3, electromagnetic induction, okay? So it's a little bit same like what you have learned in 3.2, which means that the force, okay, on the current carrying conductor in the magnetic field, but this will be slightly a little bit different now, okay? But you will easily make these two like mix up if let's say you don't know how to differentiate them correctly, okay? So we wait another 3 more, then we will start our class. And just a reminder, your PPT, okay, your PPT will be the whole Form 4 syllabus. Form 5 it will be Chapter 1, Chapter 2, and Chapter 5. Chapter 1, 2, and 5. $25 are not increasing at all. Not
sure yet when is your PPT, but it will be after the school reopen. Should be after Raya, okay? Not right after Raya, like it's after Raya, okay? Okay, I think I don't want to wait anymore already, okay, because it's 10:37 already, okay. Today, I have quite a lot to teach, okay, so we will proceed, okay. I want to okay, wait, I share my screen first. Okay. 哇，老这样快，那也可能才7分钟，那现在跟我讲9分钟，不老出来。OK， 来。Okay, can you see my screen? Yeah. So can we let us start now? Okay. Okay. So today we will learn about electromagnetic induction. Okay, induction. Okay. So electromagnetic induction. Induction is the meaning of produce. Produce of what? This is what we are going to learn for today's lesson. Okay. Okay. Before we enter today's lesson, let us refresh a little bit what we have learned in the force. Okay, force in producing a force in a current carrying conductor. Okay, so in order to produce a force, okay, you need two things. What is that? You need two magnetic field, which is one magnetic field is produced by, and another magnetic field is produced by what? Hello. What happened to you all? Wake up already? Okay. Like I give you a hint, so you all tell me what is it. Okay. It's a magnetic field caused by a current carrying conductor, which is an example of what? What is an example of current carrying conductor? Oh, y'all no one want to act one, no one want to tell me, oh, I was call names already one. Solenoid. Okay, the solenoid is what is it? What is it about? Solenoid is what? Actually, what is solenoid? No, it's not a soft iron core. It's an electromagnet. Electromagnet. So a magnetic field produced by electromagnet, and the magnetic field from where? From where? Yes, before catapult, we want to know that the magnetic field, no. From a what kind of magnet? Permanent magnet, correct. Permanent magnet. Okay, so which means that if let's say you combine a magnetic field produced by a current carrying conductor with a magnetic field produced by a permanent magnet, you combine together, they will produce a what we call as catapult field. And this catapult field will produce a different level of the magnetic field. One, it will be a stronger, one will be a weaker part. Okay, because of this difference in the magnetic field, it will produce a force. Okay, it will produce a force. Okay, it will produce a force. And how can we identify the direction of the force? Using which one? Your left hand or your, Fleming, left or right? Correct, left hand rule. Okay, left hand rule. Okay, Fleming's left hand rule to identify the direction of the force. Okay, or you can use the slap. Okay, right hand slap rules. Okay, you must remember Force is using Fleming's left-hand rule, because later on this subtopic, we will also learn one more Fleming's, which is Fleming's right-hand rule. Okay, so today we will use Fleming's right-hand rule. Okay, can I? Okay, good. So let us see here. Okay, what can you see from this diagram? Can you tell me what can you see from this diagram? This diagram, we have one solenoid, okay, and we have one permanent magnet, and this solenoid is connected to the galvanometer. Okay, sorry, this is a voltmeter, but it's actually a galvanometer. What can you tell me? What can you see from this diagram? Moving, yes. What is moving? Magnet is moving, correct? Magnet is moving. The pointer is also moving. Okay, the pointer is moving is indicating what? What is it indicating? The reading of the galvanometer external magnetic field is, yeah, correct, it's external magnetic field, but it's the magnetic field caused by the permanent magnet. Usually we will say that AC, not AC yet, but it's actually current, okay, current, okay. Okay, Kazing, remember, for voltmeter, ammeter, and maybe galvanometer, they only will may help you to measure or indicate the presence of direct current. It's not AC current, okay? It's not AC, okay? So, okay, what you have to tell me just now is that, okay? Wait, okay, so we have a magnet here. You see the magnet is moving, and this solenoid is connected to a galvanometer. It's not connected to a battery at all, you know. Okay, so which means that the movement of this magnet into a solenoid, okay, okay, so means that the magnetic field, okay, and the solenoid here, it will help you to produce, or what we call as induced current. Okay, so this is what electromagnetic induction is. Okay, you combine a force which is produced by the movement of this permanent magnet and the magnetic field between these two, cutting of the magnetic field in the solenoid, okay, between the solenoid and the permanent magnet, okay, it will help you to induce a current. Okay, so this is like, for example, the dynamo in a bicycle. Okay, do you know what is dynamo in the bicycle or not? The one in the night time, okay, in the night time, if let's say you are cycling, you want to have light, okay, so instead of using a light connected to a battery, you cycle it, you pedal you pedal your cycle, okay, then the light, the bulb, it will produce the light. Okay, why is it so? Because when you are pedaling, okay, you are producing the force, okay, you are producing a motion, and the motion will cut to the magnetic field, and it will produce the current to light up the bulb, okay, in the dynamo. Okay, so this is what we are going to learn for today's lesson. Okay, can I? So that's why, okay, if you see in this diagram here, you have a magnetic field, okay, a magnetic field produced by a permanent magnet, okay, so this one north and south, and this is the galvanometer, and this is the straight wire. Okay, if you move the straight wire up and down, okay, you will see a deflection, okay, produced in the galvanometer, which means that the deflection is mean by there is a current produced across this copper wire when it's moving across the magnetic field. Okay, so when we say about current is induced, EMF also is produced. Okay, as you know, EMF is a voltage. Okay, you must have voltage, there only it will produce current. So in other words, induced current is also induced EMF. Okay, so electromagnetic induction is actually, okay, the production of the electric current in a conductor when there is a relative motion, okay, motion of a conductor moving in an external magnetic field. So in short, you have the external magnetic field, which is this permanent magnet. Then you produce the motion using the straight wire. Okay, when there is a motion between this external magnetic field, current is induced. Okay, current is induced. That's why this is what I have asked you to copy now last week. Okay, as notes number 1, is it? This one is number 1. Okay, so motion of the copper rod cuts the magnetic field line. Okay, in here, our magnetic field line we will call as magnetic flux. Okay, magnetic flux. Cutting of the magnetic flux. Okay, what do you mean by cutting? It means that cut is the force. The force is cutting the magnetic flux, then it will induce EMF, and EMF will induce current to flow around the straight wire. Okay, clear? Okay, so in